Hello, class. Today we're going to learn about the derivative of n to the x. That is, we're going to talk about what this thing is. And we're also going to talk about the derivative of log base n of x. Okay. I'll do those in a minute. But I want to note a couple things that you might confuse the derivative of n to the x with. So first of all, n to the x is different from x to the n. So this was one of the very, very first derivatives we learned, namely the derivative of x to the n. That's still just n times x to the n minus 1. Nothing has changed in that regard. It's all staying the same. Okay. The difference is here the variable is the thing being raised to the power versus here the thing being raised to the power is a number, and then the variable is the power. Okay. So the thing this is actually closely related to, but not quite the same as, is that we've lots and lots and lots of times taken the derivative of e to the x. Okay. And the derivative of e to the x, we've said, hey, that's e to the x. It's always e to the x. And so e is a number. It could be n. But actually what makes e special is this property. So if I try and take the derivative of something like 2 to the x, it's pretty tempting to just guess that it's going to be 2 to the x, but it's not. Okay. E to the x is the only one where that's going to work. Okay. But what is it if you actually take the derivative of n to the x? Then in fact the thing you get is the natural log of n times n to the x. Okay. So that means that the derivative of 2 to the x is actually the natural log of 2 times 2 to the x. Now, you might say, well, hey, what about e to the x? Well, the derivative of e to the x, that's also the natural log of e times e to the x. It just so happens that the natural log of e is 1. Okay, and so we get the same formula. Okay. By analog, we know that the derivative of natural log of x is 1 over x, and so we might hope that the derivative of log base n of x would also be 1 over x. But it's not, but it's close to that. Namely, it is 1 over x times, and then the thing we need here is a natural log of n. Okay. So the real information you need to glean from this video is these two new formulas above the line, but I wanted to make sure we talked a little bit about how those interwove with the formulas we already have. And so you can identify which of them it is you need to use in a particular circumstance. Okay, so I want to do an example. So let's say we want to take the derivative. So find g prime of 3 if g of x is, and so it is going to be the log base 3 of 1 plus 2 to the x. Okay. Just real quick to make sure we remember how logs work. Apologies. Let's just calculate g of 3. We don't technically need to, but I'm going to remind you. So if I calculate g of 3, then that's going to be the log base 3 of 1 plus 2 cubed, which is going to be the log base 3 of 9. And so remember that when I go to find the log base 3 of 9, what's happening is I'm saying 3 to what power is equal to 9? And the answer is that this is 3 to the second power, and so that means the log base 3 of 9, that's 2. Okay, so that's g of 3. Okay. When I go to find g prime of 3, now I'm going to need to use the chain rule again, because my g of x here is a combination of two functions. Namely, it's a combination of the log base 3 of x and 1 plus 2 to the x. So I'll go ahead and say, okay, the outside function here is the log base 3 of x. The inside function is 1 plus 2 to the x. And fortunately, this will give us an excuse to use both of our new formulas of today. What a coincidence. So we can take here the derivative of the log base 3 of x, and that is going to be 1 over x times the natural log of 3. And when I take the derivative of 1 plus 2 to the x, the derivative of 1 is just 0, so that's going to go away. And I'm going to get the natural log of 2 times 2 to the x. Okay, so then g prime of x now, using the chain rule, it's going to be f prime of g of x. So that is, it's going to be 1 over 1 plus 2 to the x times the natural log of 3 times, and then g prime of x, which is the natural log of 2 times 2 to the x. So if you want to then calculate g prime of 3, this is going to be, and so it's going to be the log of 2 times 8 divided by, and then that'll be 9 times the log of 3. All right, and that will be our answer. In the next video, I'll do an example of using the first derivative test with one of these. Until next time.